Hey, how's it going? Welcome back to Ash Instructs. Today we're going to be focusing on chemistry. Now, specifically, we're going to be focusing on balancing chemical equations. Now, it's not too hard. It's pretty simple, actually. So let's just get straight into the video and let's become balancing or chemical equation balancing masters, I guess. Okay, so let's just get straight into the video and with the first example. Okay, so with the first example, we have question number 1. So we have on the left-hand side or the reactant side, we have xenon and we have iron. Now on the right-hand side, we also have xenon and iron. And in this form, we have it in a compound form, and this is a reaction of synthesis. Now today, we're not going to be talking about reactions and stuff. We're going to be talking about how to balance chemical equations. So let's do just that. Okay, so the first step to balancing a chemical equation is to jot down the elements on each side. So on the right hand side, or the left hand side, we know that we have xenon and we also have fluorine. Or sorry, not fluorine. I'm sorry, I apologize if I've been saying fluorine this whole time. It's actually iron. Okay, sorry. So we have xenon and iron and on the right hand side, we also have xenon and iron. Okay, xenon and iron. So what we need to do now is we need to find the subscripts. We need to identify the subscripts of each element and jot them down. What this tells us is how many of each atom there is. So how many atoms of each element there is. So let's jot down the values. So we know we have 1 of xenon, 2 of iron, and on the right hand side we have 1 of xenon once again and 6 of iron. Okay, so how can we balance these out? So we know that we have a xenon is balanced right now, right? It has 1 on 1 on each side, so we have a balanced xenon. However, for iron, that's not the case. Okay, sorry, I keep on getting confused with fluorine and iron. Rookie mistake. Okay, so for iron, we know that we don't have a balanced, both of them are not balanced, those two values. So the easiest way to do this is to find the LCF, or lowest common factor of these two numbers. So for 2 and 6, that we know that the lowest common factor would be 6, right? So we already know that this is 6, so we don't really need to touch this area right now. But we can affect this right here. So the way to do so is by placing coefficients in front of these elements. Okay, so what this will do, so for example, if I put a 3 here, I know that 3 times 2 will give me 6. So therefore, it results in a balanced chemical equation. So we have 1 and 1, 2 and 6 and 6. So this is a balanced chemical equation. So this is basically how you would solve a balanced chemical equation. However, let's just get a little bit more advanced and into some bigger equations. Okay, so let's go into question number 2, or example number 2. Here we have silver, hydrogen, and sulfur on the left hand side, or the reactant side, and we also have on the right hand side, we also have silver, we also have sulfur, and we also have hydrogen. So first things first, of course, jot down the elements. So we know we have silver, we know we have hydrogen, and we know we have sulfur. Okay, so on the right hand side, we also have silver, we also have hydrogen, and we also have sulfur. Okay, now what we need to do now is we need to find out how many of each element we have. So we have we have 1 of silver, we have 2 of hydrogen, and we have 1 of sulfur. Now on the right hand side, we have 2 of silver, we have 2 of hydrogen, and we have 1 of sulfur. So we know that the two hydrogens are balanced. We know that sulfurs are balanced. However, with our silvers are not balanced. So once again, the easiest way to do so is by adding coefficients. That's how we do it in balancing. So by adding a coefficient of 2 for this case, for 2 times by multiplying 2 by 1, which is this little subscript that's here. Just note that if there is no subscript or it's invisible, that just means that there is a 1 there. So for visual representation, I'll just put the 1 there. But if there is no subscript there, just assume that there is 1 there. Okay, so we know that 2 times 1 would give us a value of 2, therefore resulting in a balanced chemical equation. So as you can see, we have 2 of silver, 2 of hydrogen, and 1 of sulfur. Okay. Moving on to the last example for today. I know that this isn't too advanced yet. Stay tuned for a advanced video that will be coming out sometime soon. However, in this video, we're just gonna be, covering the bare minimum, or like the basics of how to balance these chemical equations. Okay. So moving on to a little bit of a harder, or not harder, but a more advanced example. So we know that on the left-hand side, we have potassium, we have oxygen, we have hydrogen, and we have carbon. Now notice how I didn't put oxygen twice, okay? The reason I didn't put oxygen twice is because we have no need to label two elements more than one time. If there is more than one element of the same element on one side, what we can simply do is we can add those two values together. And I'll get to that right when we get to oxygen. However, let's start off with potassium first. So now we know that K, or potassium, has one value. Oxygen has 1 plus 2 value, okay, so 3. Okay, so we know that this is 1 right here, just for visual representation. 1 plus 2 of oxygen equals 3, gives us 3 of oxygen. Okay, we have 1 of hydrogen, and we also have 1 of carbon. Pretty simple. Okay, moving on to the right-hand side, we also have potassium, oxygen, hydrogen, and carbon. Okay, so what do we have of potassium? We know we have 2 of potassium. We have 3 plus 1, so 4 of oxygen. We have 2 of hydrogen, and we have 1 of carbon. Okay, so let's get into adding coefficients now. So we have oxygen and we have potassium. Those are the two elements that are not balanced. So as you can see, oxygen and oxygen has values 3 on the left-hand side, 4 on the right-hand side, and the lowest common factor for those two numbers would be 12. And as you can see, we're getting to a little bit of the greater number range. So let's stick with some small numbers first, and let's get those out of the way, and then we can tackle the big obstacles. Okay, so we know that just to balance these two equations out, we're gonna have to make this value equal to 2. Pretty simple. So what we're going to do is we're going to add a coefficient for potassium of 2, and what this does is it multiplies 2 by 1, this little subscript over here. So 2 times 1 will obviously give us 2, therefore resulting in a balanced potassium level. Okay, now however, what we do for one element in a compound must happen to every single element in that compound, okay? So if we multiply 2 for potassium, we're going to have to multiply 2 for oxygen and 2 for hydrogen. So 2 times 1 gives us 2, and don't forget that extra 2 over here. So 2 plus 2 gives us 4. So 4 of hydrogen, therefore resulting in a balanced oxygen, and 2 times 1 of hydrogen giving us 2 of hydrogen, therefore resulting in a balanced chemical equation. As you can see, we have 2 of potassium, 4 of oxygen, 2 of hydrogen, and 1 of carbon on both sides. So that, ladies and gentlemen, is how you can balance chemical equations. I know this isn't the most advanced version of how to do so. We will get into that in part 2 of this video. However, I hope you enjoyed watching this, and I hope you learned something, or I clarified, how you can balance chemical equations. And I hope to see you in the next tutorial, where we will tackle on new obstacles and learn new things. All right, see you next time.